All right, nearly there. Finishing off with a bit of trigonometry. The tan of C. What's the tan of C going to be? So these questions are easier than they first appear. All you need to do is, there's angle C. What's the thing we always do first with trig ratio questions? Label the sides. So what do we got? Across from the right angle is the hypotenuse. C is the angle I'm interested in, so I like to draw a little arrow across to remind me that's the opposite side. And adjacent means next to, so that's the adjacent side. Now what is the tan ratio? You will remember SOHCAHTOA. That's what helps us recall all the information we need to. So the tangent ratio of an angle is the opposite side over the adjacent side. Well, so tan of C is going to equal the opposite side is 20 divided by the adjacent side, which is 15. So the tan of C equals 4/3. Now we don't need to go any further. It doesn't say find the angle C. It just says find the tan of C. So we're done. Over here, let's label again. Hypotenuse. We're interested in angle C. So next to it is the adjacent side. Across the triangle is the opposite side. Sine is opposite over hypotenuse. So the sine of C in this case, the opposite side 9 over the hypotenuse, which is 15, and simplify, dividing top and bottom by 3, we get sine of C equals 3/5. These are a bit nicer, aren't they? Cosine of Z. There's angle Z. Make sure I label hypotenuse across from the right angle, opposite side, adjacent side. SOHCAHTOA, cosine is adjacent divided by hypotenuse. So cosine of Z is equal to 28/35. They're both divisible by 7, so we're going to simplify that. Cosine of Z equals 4/5. Find the tan of Z. You're in the swing now. Let's just do it. You don't need any more commentary. Let's just get a few done. No simplification required. And lucky last, cosine of A. There's my angle. Label everything appropriately. And dividing by 7, cosine of A equals 3/5. So I'm sure you raced through those or probably skipped and never even watched that part of the video because you're killing it by now. This time we actually have to find the size of the angle. So let's go ahead. I need to label the sides. Hypotenuse. That's the opposite side. That's the adjacent. So I now need to select the appropriate ratio. I know the adjacent and the hypotenuse. That's cosine, isn't it? So the cosine of question mark equals 7/8. So the question mark equals the inverse of cosine, which is arc cos. Remember, I encourage you to write it that way, even though your calculator writes it as cosine with a little -1. And just as an aside, for those who I haven't talked to about this before, when I'm doing arc cosine of theta, are we trying to do the inverse cosine operation, which is arc cos of theta, or is this cosine theta all to the power of -1, which would of course be 1 over cosine theta? They are not the same thing. Now, because we use this sort of notation, when I say cos squared theta, that means cosine of theta squared, and even cos -2 of theta is going to mean cosine of theta to the power of -2, which is 1 over cosine theta all squared. You can see how this notation is used to indicate a power usually. It's only the exception when they use -1 that sometimes it means the inverse cosine operation, which should really be called arc cos. And you'll understand more why it's called arc cos when we get into measuring our angles in radians instead of degrees. but it's to do with the unit circle and the arc around the circumference of the unit circle. So I encourage you not to use cosine -1 for the inverse of cosine. Yes, it'll look like that on your calculator and do that, but get in the habit now of writing arc cos just to make sure it's really clear to everyone exactly what you're doing. Now we're going to need our calculator for this. Arc cos of 7/8. Let's see where, there's my calculator. Now I don't know how to do it on this one. Let's have a look. Is there a shift button or something? Doesn't look like I can see one there. I can do cosine. That's not very good. Let's go to Desmos. Desmos will sort it out for us. Now, what we do need to tell Desmos is we're working in degrees. You can see the radians that I was talking about. It's going to be more common in the future. But let's just work in degrees for now. And we want arc cos of 7/8. And you'll see that Desmos likes the arc cos notation as well. So 28.955, so approximately 28.96 degrees. Over here, let's go again. So here we've got an angle. Oh, look, this is adjacent. That's opposite. And that's a hypotenuse. So it's a cosine again. So the cosine of the question mark is equal to the adjacent divided by the hypotenuse. What's the question mark angle going to be? It's going to be arc cos of 13/31. Question mark is approximately equal to 13/31, 65.2 degrees. Down to 111, looks like we have. There's a hypotenuse. This side would be opposite, and that's adjacent. That's a tangent ratio, isn't it? So the tan of the question mark equals 33/41. Question mark again, instead of writing tan -1, let's get in the good habit now of writing arc tan 33/41. Question mark is approximately equal to, come on Desmos, too busy thinking of other things, 33/41. Didn't like that. Get them in the right place. 38.8 degrees.
Can you pause? I need to be able to use my mouse.
Alright, so here we go. Question 112. What have we got this time? This is the hypotenuse. That's an opposite. This is an adjacent. Looks like we've got opposite adjacent. That's tan again, isn't it? So the tan of the question mark, the tangent ratio for that angle is 15/25. So the question mark equals arc tan 15/25. And yes, we could have simplified that to 3/5, but your calculator's not going to know any different, so that's okay. Going across, arc tan of 15/25. Let's see if I got them in the right place that time. I did. 30.96. You can see here I'm switching between 1 and 2 decimal places. In the exam, it will probably be 2 decimal places unless it's stated otherwise, or it might say 3 significant figures. You go with what's comfortable and what makes sense for you. Find the missing sides. Let's go through the procedure again. Label hypotenuse, opposite, adjacent. Okay, I know the adjacent, looking for the opposite, so that's tan. The tan of 65 is going to equal x/11, so 11 tan 65 is equal to x. And it's just a matter of typing it in, isn't it? 23.59. X is approximately 23.59 units. I wasn't given any sort of indication of what units they were using, so that'll be fine. This time, X is my hypotenuse, 13. Oh, it's a bit tricky. I nearly wrote adjacent, but that right angle that's opposite there, 74 is opposite 13, adjacent to 74. is that one there. That 74 is just sort of placed in the middle. Just be careful when you're labelling them. Make sure you get them in the right place. So I know the opposite. I'm looking for the hypotenuse. That's sine theta. So sine of 74 equals the opposite 13 divided by the hypotenuse. Now I don't want that x on the bottom, do I? So I'm going to multiply each side by x. X sine 74 equals 13. And finally, I want x on its own. The opposite of multiplying by sine 34, dividing by sine 74, I should have said, but you guys knew that already. What's x approximately equal to? 13 divided by sine 74. 13.5. Yeah, and that's reasonable. This is a really short side, so that won't be a lot longer than the vertical side there. That makes sense. Right down the pointy end now. 115, you've done well. Hypotenuse. Across from the hypotenuse is the opposite side. That's the adjacent side, so I know the opposite. Looking for the hypotenuse, this is a sine theta ratio. Sine of 35 equals 10 over x. Multiply by x. X sine 35 equals 10. Divide by sine 35. Divided by sine 35. And that comes out as 17.4. Here we go again. That's, oh my goodness, they randomly chose the sine ratio frequently here, but it's the same whichever ratio you're using. The important bit is to get in the habit of choosing appropriately. So opposite and hypotenuse, this is sine of 60 equals the opposite side divided by the hypotenuse. So I multiply by 15, I've got 15 sine 60 equals x. Now, you possibly haven't done it in class yet, but we can find an exact value for sine 60. I won't worry about it for this time. I'll leave that excitement for your teachers to teach you. But let's go to the next one. 15 sine 60, 12.99. And again, we can just write units behind that if we want. Find the measure of the indicated angle, labeling our sides, hypotenuse. Across from the angle I've got is the opposite, that's the adjacent. So I've got the tan of question mark is 19 over 49. Question mark is going to be arctan of 19 over 49. The question mark is approximately equal to, here's one I prepared earlier, 19 over 49. 21.19 degrees. Nearly there, 118. That's going to be opposite, hypotenuse, adjacent. Oh, adjacent and hypotenuse is cosine. So the cosine of the question mark is 8 over 21. Question mark is going to equal arc cos of 8 over 21. Question mark is approximately equal to, let's make that 8 over 21. 67.7. And again, this is an angle, so we'll stick our little degree sign there. 119. This is my hypotenuse. 2 is going to be the opposite side. 4 is the adjacent. So opposite and adjacent, that's tan. The tan of question mark equals 2 over 4. Yes, you could have written a half. Question mark equals the arctan. Let's write 1/2. I'm sure you can all cope with that. Arctan of 1/2. 26.57. Approximately equal to slack chewy. Make sure when you're rounding an answer that you're writing approximately equal to, or you write equals, and then after that you could write 2dp to indicate decimal places, I guess. This is my opposite side. That side's opposite the angle. This is the hypotenuse across from the right angle, and that makes that one the adjacent. Hypotenuse and adjacent is cosine. cosine of the question mark is 36 over 44. You could make that 9 over 11, but let's not waste our time and increase the chances of making a mistake. This is just on our calculator, so it's fine on a calculator exam to leave it as it is. Cos of 36 over 44. 35.1. 1 degrees. Wow, there you go. That's the trigonometry done. 2 to go. Let's just power through. Aircraft carrier left Hawaii the same time as a submarine. The ships travelled in opposite directions. The submarine travelled at a speed of 15 kilometres per hour. And let's start drawing this. I think it's going to help us. There's Hawaii. Let's say the submarine went this way, and oh look, they chose, miles per hour. See, I even said kilometres, but this is 15 miles per hour after 6 hours, and so that's the submarine, and the aircraft carrier is going in this direction. The ships travelled in opposite directions. This one was travelling at 15. After 6 hours, they were 180 miles apart. So in 6 hours, the submarine has travelled 6 by 15, which is of course 90 miles. Now, if they are 180 miles apart, therefore in 6 hours, the aircraft carrier travelled 180 minus 90, and you've already figured out 90 miles. So it's travelled 90 miles, therefore the aircraft carrier speed, we don't even need to do the calculation. I could do distance divided by time, but we already know it was the same as the submarine, 15 miles per hour. And your very first revision sheet is coming to an end here. Probably a little bit sad for most of you, but let's get through it. A submarine left the Dania Pier, don't know where that is, and travelled north at an average speed, there's Dania Pier, of 20 kilometres per hour. There's kilometres. 20 kilometres per hour. And this is a submarine. Sometime later, an aircraft carrier left travelling in the same direction, but an average speed of 30 kilometres an hour. Didn't really leave myself enough room to write that, but we got a basic idea. Let's have a look. So, whoops, upside down. Sorry for that pause there. So 30 kilometres, 20 kilometres an hour. Okay, it says after travelling for 4 hours, the aircraft carrier caught up with the submarine. So how far did the aircraft carrier travel? Oh, I think this is pretty easy, isn't it? It was 4 by 30 kilometres per hour, multiplied by 4 hours. That's 120 kilometres. So find the number of hours the submarine travelled. It travelled 120 kilometres at 20 kilometres per hour. At 20 kilometres per hour. So how many hours is it going to take at 20 kilometres an hour? It's going to travel for 6 hours before it reaches 120 kilometres. You're done. You made it. Well done, guys. See you in the next revision sheet. Not that far away. Enjoy. All right, just going through and seeing how I went, and I noticed that I wasn't very good at reading the question, was I? It says up here, find the measure of the angle to the nearest degree, and I just went ahead and found the angle and talked to you about rounding it maybe to 1 or 2 decimal places, and it'll tell you in the question in the exam. It told us in the question here. So now we can write, because I want it to the nearest degree, we can do an equal sign. This is equal to 29 degrees to the nearest degree. This one would be 65 degrees, and you get the idea. Sorry about that. This one here, 39 degrees. 30.96, that would be 31 degrees. Round to the nearest tenth. Look at that, not paying attention. This would be 23.6 units. Oh, I did that one to the nearest tenth, that one. This one here would be 13.0. You need to write the 0.0 to show that it's been rounded to the nearest tenth, and then back to the nearest degree again. So 21 degrees, 68 degrees. That'll go up to 27 degrees, and 35 degrees. Is that all the misbehaviour? Yes, I think that's it for that. Sorry about that. Hope that clears that up. Cheers.